Long, long ago, in a galaxy far, far away, a lowly math teacher attempted to teach his Algebra 1 students about the slope of a line. Was his quest successful? The world may never know. Hello, my dears. How you doing? Class 4, Unit 4. So today, we're hitting the slopes. We are talking about the slope of a line. Now, before you go any further, pause the video. Please check the description of the video, the assignment description. There is another video by another creator that I've asked you to watch to introduce the concept of slope. One of the things about being a teacher is recognizing there are things that you're good at and things that you're bad at, just like as a student. For me, slope has always been something that I've struggled to talk about, being vulnerable here. So, there's another video that does a way better job than I can. I've asked you to watch that video first, take some notes there, and then take what you've learned and come back here. So if you're still with me, I'm assuming that means you've watched and taken notes on this other video. Let's sum up some of its key points and talk about one other dimension of using slope. Looking at our lines, here on this graph, I've given you some red, some blue, and some purple lines. The idea is that up until this point, we've worked with standard form. Standard form is great, but if I'm thinking about building graphs, there is in fact another form of a line that is more powerful for me for constructing the graph. Understanding the parts of a line, in other words, what changes from line to line, from equation to equation, is going to help me figure out which of the forms of my line will in fact be the most powerful. One of the things that changes from line to line here that hopefully you've noticed is it's different where each one crosses the x and y axis. We again call those our x and y intercepts. One of the things that mathematicians love is efficiency. And one thing that we can do to be more efficient is to use symbols instead of saying x-intercept and y-intercept. Mathematicians settled on the lowercase letter a to represent the x-intercept of a line. So for example, take this red line. It crosses the x-axis right over here at this point, -6, 0. So we say -6 is the x-intercept. So the value of a is -6. That tells me I cross the x-axis at the value of -6, and the coordinate, or the point on the graph, would be -6, 0, or whatever the value of a for the x-intercept would be. The y-intercept, if we use a for the x-intercept, we'll use b for the y-intercept. Again, taking this red line, notice that it crosses the y-axis here at this value, which would be +1. So we say the value of b for the red line is 1. Its y-intercept is 1. It crosses the y-axis at the point 1, or not 1, sorry, but 0 for x and 1 for y. 1, of course, being our value of b. For slope, again, we could say slope every time, or we could use a symbol to be more efficient. The symbol that mathematicians choose for slope is the letter m. So we use a lowercase variable m here to represent the slope of a line. By definition from our video, we came up with an idea that as simply as possible, one easy way to think about slope, it is a measure of how steep our line is. So we'll say that slope is defined most easily as a measure of the steepness of a line. Interchangeably though, what slope is really doing is telling me how quickly my line moves up or how quickly my line moves down. That means that it is a rate of change. It's telling me the speed at which my line is changing. So another interchangeable definition for slope, we can call it the rate of change. And an important point that was made in the video that I have asked you to watch before this one is that for slope, it is in fact constant. Slope of a line is always the same, which means if I take any place on my line between any 2 points, the rate of change, the speed at which it goes up or goes down, the line is straight. It has no bends, it has no curves, so the slope will always be the same. So we can define slope as the rate of change between, abbreviated b/w, any 2 points on our line. It does not matter which 2 points I choose, because again, the slope is always the same on the line no matter where I look. Intuitively, if a line has a big slope, I'd say it's really sloped. Remember, what I'm saying is that the line looks a lot steeper. Something is really sloped, it's going to be really steep. So lines with slopes that are larger are going to appear steeper, either going up or going down. The smaller that my slope gets, the less sloped I would expect it to be, so it's going to look a little bit flatter. So lines with smaller numbers attached to their slopes, they look a little bit flatter than numbers that are bigger. Positive slope, if I'm thinking about a slope being positive, it's kind of like I'm climbing up my mountain. So we defined it as I move from left to right, my line goes up. The formal mathematical word for this, we say that our line is increasing from left to right. And the way that I like to figure out whether or not a graph, it could be a line or it could be any graph, if it's increasing, I like to imagine taking my finger and tracing along the line. So the idea is if I take my finger and put it all the way at the left on my line, as my finger moves to the right, notice that my finger here would move up the line. So I'd say that my line is increasing. A negative sloped line, well, that would be kind of like going down my mountain. It's angled downwards. We say that this line is decreasing from left to right. The idea being if I were to take my finger and trace from left to right along this line, you would notice your finger going down. So we know what slope makes our line look like, but what if I want to actually calculate the value of slope? Well, here, what slope really does, it's a comparison. Just like a rate of change like miles per hour compares the number of miles that I travel to the number of hours I travel for, slope compares how much I go up or down, so the change in the y direction, to how much I change left or right, so the change in the x direction. Find the slope of this line for me real quick. Again, you can use any 2 points. Tell me what its change in y and change in x are and how you would use that to find the slope. Go. Okay, so let's say that I take these 2 points towards the top of my line. This value here, how much I go up or down, we call the run. No, I lied. We call it the rise. That makes more sense. The rise of a line is how much I go up or down to get from one point to the next, whereas the run would be how much I go left or right to get from one value on my line to the next. So on this line, notice that its rise will I go up here counting on my grid line 1, 2, 3 units. So the slope represented by the value m, it's equal to the comparison of rise to run. We often say that slope is rise over run because a fraction is an example of a ratio. It's a rate, it's a comparison. So I'm comparing how much I go up or down to how much I go left or right. In this case, the rise is 3. And the run, well, how much I go left or right? I go 1, 2 over here. So the slope of this line would be 3 divided by 2. 3/2 is the slope. However, while I have the ability to use my graph to my advantage, sometimes I might just ask you to find the slope between 2 points, which means I won't always have this visual to count the rise and the run. Where do you notice that the 3 and the 2 could come from? Well, if you look at your points, I'm taking 5, 8 and 3, 5. Look at the 8 and the 5. The rise, the change in the y direction, well, I'm changing from 8 to 5. How could I use that to get 3? Well, you might notice here that 3 is equal to 8 minus 5. And the run of 2, well, if I take the x-coordinate of the first point, which is 5, and subtract the value of 3, that also gets me 2. So another way to calculate rise and run would be to find the difference between the y values and the x values. So from this idea, if I generalize, another way to find slope, given 2 points, let's say I call my first point x sub 1, comma y sub 1. Remember that this notation is just saying the first x value and the first y value. And let's call the second point equivalently x sub 2 and y sub 2. So the second x value and the second y value. To find the slope of a line, all I need to do is take the difference of the first and second y values and divide it by the difference of the first and second x values. This is what we call the slope formula. Given any 2 points to calculate the rise, the change in the y direction, I just need to find the difference of the y coordinates. To find the change in the x direction, I just need to find the difference of the x coordinates. Cool. Let's do a little bit of practice using this idea. Again, you're always welcome to just use the graph and count the rise and the run. But we won't always have that luxury. Here it turns out we do. Take 10 seconds, 30 seconds, a minute, 2 minutes, whatever you need. Pause the video, play around. Find some points on your graph here and tell me what the slope needs to be by calculating the rise and the run. Go. All right, let's do it. So on my graph here, again, I can take any 2 points that I want. The first 2 points that I noticed happen to line up nicely with my grid lines are these guys. So I've got 3, 2 up at the right and -3, -2 over here on the left. If I want to find slope, again, I could count the rise and the run, but to get practice using my slope formula, remember that slope is found by taking the difference of the y values and dividing by the difference of the x values. As I'm using my slope formula, what I like to do, as I'm getting familiar with it, is label my points to make it clear which one is the first point and which one is the second point. When I use this, I can see that all I need to do is substitute in. So y2, I've labeled as -2, minus y1, which is 2, over x2, which is -3, minus x1, which is +3. If I take this and simplify, -2 minus 2 is -4, divided by -3 minus 3, which is -6. -4 over -6, well, that reduces to +2/3. So this tells me the slope of my line is 2/3, and would you look at that? If I count some points and find the rise and the run, notice there's another point right over here. On the origin 0, 0, to get from point to point, right, I could think about running 1, 2, 3 over and rising by 2. Using my graph, I can confirm that my slope formula does in fact give me the same rise and run that I can identify graphically. Cool. For my second one, let's find some points. Well, the first 2 points that I notice, I've got one right here on the y-axis. This guy's coordinate would be 0, 2. And I've got one right here below the x-axis. This guy's coordinate would be 2, -1. Again, using my slope formula, I know if I take the difference of the y values and divide it by the difference of the x values, then I should be able to find my slope. So I'm going to label maybe the point at the top. We'll call our x1, y1 our first point, and our second point will be the 2, -1. Substituting in, all I need to do is replace y2 with what I've identified as -1. y1 I found is 2 minus, or over x2, which is +2, minus x1, which is 0. Simplifying, -1 minus 2 is -3. 2 minus 0 is 2. -3/2 is going to be our slope, and it's a negatively sloped line, so it makes sense that there's a negative number. Again, I'm saying here that the rise is 3, so looking at that, 1, 2, 3, I go down in this case, and then over to the right 2. Look at that, my rise and run check out. One last one for the road. let's get some practice using our formula abstractly. So in the absence of a graph, I've got the points 7, 14 and negative 2, 32. Tell me the slope of this line. Use your slope formula, find your differences. Let's do it. Go! Alrighty, here we go. So I'm going to take my slope formula. Slope is equal to y2 minus y1 over x2 minus x1. Doesn't matter which one is which. Let's say here that I choose the point on the left to be my x1 and y1. I choose my point on the left, or on the right, sorry, I know directions, that's why I teach math, to be my x2 and y2. All I've got to do now is substitute in. So y2 we've identified as 32, y1 we've identified as 14, x2 we've identified as negative 2, and x1 we've identified as 7. To simplify, 32 minus 14, well, that is equal to 18. Negative 2 minus 7 is equal to negative 9. 18 divided by negative 9 is negative 2. So the slope of this line is negative 2.